This is Algebra with Jennifer. Today I'm going to look at three different graphs of parent functions that have been transformed, and then we're going to write the equation for the transformed graph. First, I'd like to take a look at this one. This is a quadratic. We know it's a quadratic because of the parabola, the U shape. Up here on the top, this is the parent function. We can tell it's the parent function because it goes through the point 0, 0. And then from this vertex, you can see it goes out 1, up 1. That's your 1 squared is 1. Then it goes out 2, up 4. 2 squared is 4. So this is my parent. This is my transformed. So we're going to talk about what it did. How did it move on the graph? So I'm going to say this vertex has moved to the left 3 places. Now it didn't go up or down. This vertex is still sitting on the x-axis, so there's no k value. It did not go up and down at all. But I do see that up here it has not been reflected in the parent, but this is now a reflection over the x-axis. I don't see a vertical stretch or shrink, and I can tell that because from the vertex, remember the parent function from the vertex goes out 1, up 1. No stretch or shrink. Here, from my vertex here, I can see it goes out 1, down 1. No stretch or shrink. So these are the only 2 transformations that we have. Now using our base equation, we can now write an equation for this graph. I'm going to start by calling it a name. I'm going to call this g of x. Remember, the a is your vertical stretch or shrink. There is no stretch or shrink, so I do not have an a value. However, I do have a reflection, and that's what sits out front of the function. So I'm going to write a negative sign to show that it's been reflected. Then the left 3, inside your grouping symbol is your left and right. And remember, it's opposite world. So I'm going to set up my parentheses because this is a quadratic, and remember, a quadratic is going to have your parentheses squared. So I'm going to have my x. Now left 3 is going to be plus, opposite, 3, squared, that shows that it's a quadratic, and then reflect and left, and it does not go up or down, so I'm not going to write anything down here in the end, and there is your equation. Let's do another one. My next example is an absolute value function. I know this is absolute value because of the V shape that it makes. The transformations that I see here are, I see 3 of them right from the start. I've got my parent function here in the black ink. I can tell it's my parent because its vertex is at 0, 0, and I see when I go out 1, up 1, it's a 1-to-1 relationship. In other words, if I have an input of 1 into my absolute value function, my output would be 1 because the absolute value of 1 is 1. The absolute value of negative 2 is positive 2. So this is the parent function. My transformations, we're going to be looking at this blue graph. I see that the vertex has moved to the left 3. 1, 2, 3. Our vertex is sitting right here now. Then it moved up 3. 1, 2, 3. That's where it's sitting. 1, 2, 3. There's one more transformation, and that's going to be the reflection across the x-axis. We can tell that it's been flipped, if you will. So reflection across the x. Let's write the equation for this. I'm going to name it g of x. Now remember, first we're going to be looking at the a value. It has been reflected, so the a value is negative. There is no stretch or shrink because, again, it goes from this vertex out 1, down 1. Out 1, down 1. That's a 1-to-1 relationship, so there's no stretch or shrink. So it's just a 1. Don't have to write it. I'm going to use the absolute value symbol. Left 3, remember opposite world, so that's going to be plus 3. and then up 3. That's now my k value. So there's my up 3. Let's do another. My last example is going to be a linear function. The parent equation is just x, or f of x equals x. I have my parent here drawn, so you can see it. Again, we know it's the parent because it goes through the vertex and it has a one-to-one relationship. In other words, if my input is a 1, my output's a 1. If my input's a 2, my output's a 2, etc. So then we're going to look at this blue line as our transformed function. But this center point, if you will, is up 1, 2, 3, 4, 5 places. And that is actually the only transformation here. So to write this equation, I'm going to name it. I'm going to call this one g of x again. Now, my parent function, again, is just x. This one moved up 5. So I don't have any stretches or shrinks. It's not been reflected. So this whole piece is just x. And then here is my up. So I'll have x plus 5. I hope this helped.